Okay, let's talk about the point-slope form of a line. It's a third way to look at a line. Its equation is this. It's also my favorite way to look at a line. So in this video, we'll learn how to read, graph, and use the point-slope form of a line, which is my favorite, and we'll probably deal with parallel and perpendicular lines a bit too. Actually, just parallel. We'll do perpendicular next time. Last video we reviewed slope-intercept form, which is this one, and standard form, which is this one. Just to remind you, with slope-intercept form, that's your y-intercept. That's your slope. So I'll go down 5, 1, 2, 3, 4, 5, and right 3, 1, 2, 3, and down 5, and right 3. If I had room, I'd go up 5 and left 3, but I don't really. I would grab my straight edge, and I would draw that line. In standard form, we can find the x and y-intercepts really quickly. So the x-intercept is c over a, which is in this case 12 over 3, which is 4. So the x-intercept is here. And the y-intercept is c over b, which is 12 over negative 2, which is negative 6. So that's here. The slope is also negative a over b, which is negative 3 over negative 2, which is just 3 over 2. So I can go from this point up 3, right 2, up 3, right 2, up 3, right 2. Those 4 points make that line. Okay, those two forms of lines you're very familiar with. We should be very confident with and able to do them very accurately and quickly. This third form is called point slope. Point slope form is useful when you have a point that isn't on the x or y axis, if you have a point that isn't the x or y intercept. This is the formula for it. And the thing that frustrates or confuses people about this formula is these minuses right here. These minuses cause all kinds of problems. Only if you let them, though. They're actually really quite simple and straightforward. So here's the idea. It's called point-slope form because it gives you a point and it gives you a slope. But that point might not actually be on the y-axis. In fact, it's probably not on the y-axis. So here, the point in this example that I'm doing is going to be negative 2, positive 4. So the x-coordinate came from this, right? The x-coordinate was the negative 2. The y-coordinate came from this. The y-coordinate was the positive 4. And you might be wondering, well, why do the signs switch? They switch because of these negatives. The negative causes the sign to switch. So the point here was negative 2, positive 4. The slope, however, doesn't have any negatives in the equation. The slope is just going to be 3. Negative 3. M is just negative 3. So you graph this really, really simply. You just go to the point you were given, negative 2, 4. And from there you do your slope. This is down 3, right 1. And there I've graphed the line. This pink line I draw is going to be really, really faint. That's not so bad, actually. This is the equation y equals, or y minus 4 equals negative 3 times x plus 2. Now you note this line actually had a really clear y-intercept, right? Like the y-intercept of this line is actually just negative 2. So this line could be written as y equals negative 3x minus 2. And in fact, if we simplified this expression here, so we got y minus 4 equals negative 3x minus 6. I'll solve for y in the equation, so I get y equals negative 3x minus 2. Yeah, we can actually convert from point-slope form to slope-intercept form by just solving for y. But as we'll see in a second, sometimes that's not always clean, and it's never actually better. Like if you can just read point-slope form, just graph from point-slope form, and just understand point-slope form. This is one of those things in math where the thing that's kind of a bit more complicated to understand is actually easier to do, and most things in math work out that way. If they're tougher to understand, the actual doing of it is easier. So let's try to understand this so we can do things easier. Okay, another example. Y minus 5 equals 2/3 times x minus 4. Take a second and see if you can identify what is the point and what is the slope. And I really appreciate it that when I ask what is the point, you don't get all snide and be like, I don't know, what is the point? This is dumb. And also that's what you sound like. The point here is going to be positive 4 for x and positive 5 for y. You switch the signs of the points when they're in the equation. So positive 4 for x and positive 5 for y. The slope is 2/3. So to graph this, I would go to the point 4, 5, and from that point do a slope of 2/3. Well, I don't have a lot of room to go up 2 and right 3 right now, so I'll go down 2, left 3, and graph this line. Notice this does not have a clean y-intercept. If I had put this in slope-intercept form, which, isn't that hard, distribute the 2/3 and add a 5, I would have been messing with fractions. And that's okay, fractions aren't bad, but we can avoid them with this form if we so choose. This is the equation of the line. That's a fine way to write the equation of the line. I'd like to do another example on the same plane while I'm here. Suppose in this case I gave you the point, and I gave you a slope. What's the equation? Can you go backwards? If I give you the point and the slope, can you write the equation? Graphing is pretty straightforward. You go to the point 3, 1, go up 1, right 2, or down 1, left 2. So the line would look like whatever that is when all those dots are connected. But the equation, we have to remember, has these negatives in it, right? It's y minus y1 equals m times x minus x1. Well, this is my x1 and this is my y1. So I'm plugging the 1, I'm plugging that into here, and I'm plugging the 3 into here. So it's y minus 1 equals 1/2 times x minus 3. That would be the equation in point-slope form. All right. A line contains the point 5, -3, and has a slope of 1/3. Write the equation of the line and graph it. This is the same thing that we just talked about. Why don't you pause this and try it on your own? Well, this would be y plus 3 equals 1/3 times x minus 5. Switch the sign, switch the sign. The x variable, right? 5 is the x variable. The x variable goes next to the x in here. The y variable goes next to the y. So I'm going to go to the point 5, -3, and graph a slope of 1/3. Kind of like that. Okay, next. Write the equation of the line parallel to y equals 5x minus 3, containing the point 6, 8. I'd like to remind you, I'm going kind of quickly here, but you can pause. So if you need to, pause. And if you need to, rewind. But it might be worth just pausing and dwelling on what's happened for just a second or two. Just thinking about what took place as we try to just race through the video and get it done as quickly as we possibly can, which I know that's your goal sometimes. I want to make a line parallel to this one. If I want them to be parallel, parallel means they have the same slope. So I'm going to pull the slope out of this line. And I actually don't care about anything else. All I care about is that slope of 5. I have a slope of 5 and a point of 6, 8. Since I have a point and a slope, I'm going to take my point and my slope and write this in point-slope form. Done. There's x1, there's y1, there's m. Bingo. If you were taking a standardized test, you would probably have multiple choice options, and those would probably be in slope-intercept form. So if you wanted to convert, you can multiply y minus 8 equals 5x minus 30. Add the 8 to both sides. This is the equation y equals 5x minus 22. Those two equations are actually the same. Just one's in one form, one's in another. Okay, so writing parallel and perpendicular lines is really, really easy in point-slope form. All you need is a slope and a point. Okay, I think we have one more. Here's a medical word problem that I made up entirely, but I've also helped somebody with a problem kind of like this once as they were in pharmacy school. So, the numbers here are made up, and the situation probably isn't super realistic, but the principle is going to be true. A drug is administered to somebody, and the amount of dosage they receive drops each day, okay? The rate of change of the dose is constant. What that means is you have a line. It's going to go down 20 milligrams every single day. Every day the amount you get drops 20. However, the amount somebody starts with may change, and that probably changes based on their size, like, their mass. There could be other factors as well, of course. Okay, so the graph to the right shows the average patient's dosage in yellow. So the average patient starts at 120 and ends on day 6. They're going down by 20 each day. But it also gives a point in green where your patient received medication. We're going to write an equation that models the dosage for our patient over time. Well, here's what we know. We know a point. On day 3, our patient received 90 milligrams. We could trace backwards to find how much did he have on day 0, or trace forwards to find where's he going to end. But we know that these lines are going to be parallel, which means we know the slope of our friend is also going to be down 20, right 1. Every day we go down 20. So the slope is negative 20. The point is 3, 90. So we can write his equation as y minus 90 equals negative 20 times x minus 3. There's the equation in point slope form. If we wanted to put this into slope intercept form, y minus 90 equals negative 20x plus 60. Add the 90 to both sides, and y equals negative 20x plus 150. We would also now know that he started at 150 milligrams instead of the average patient starts at 120. Okay, so to recap here real quick, point slope form is awesome because it's simple if you can understand it, so just work to understand it. The points switch their signs. Negatives become positives, positives become negatives. The slope stays the same, and you're graphing from a given point, not just the y-intercept. Well done. Until next time.